Good morning. This lesson is for my honors integrated 1 class and my integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'll title it how I'm going to title it in the title. But what I am sure of are our 2 goals for the day. Our first goal is going to be to investigate conditions needed to create a triangle. Our second goal is going to be the understanding of how side lengths of a triangle impact the opposite angle measure, and how angle measures of a triangle impact opposite side lengths. So I would like to first, let's just go ahead and first jump into our first goal. That wasn't very smooth. Let's jump into our first goal here, and it's going to be investigate conditions needed to create a triangle. I'm from New Jersey, and when I look at this lesson, it reminds me of a feature that New Jersey has. New Jersey is on the Atlantic Ocean, and it has what's called barrier islands, which are basically sandbars that are a mile from the mainland. And there's a bunch of bridges that go to these little islands, these sandbars. And so these bridges that go are drawbridges. And let me explain what a drawbridge is. A drawbridge is a bridge that opens to allow sailboats and tall boats to pass by. And so you might be thinking, why don't they just build the bridge taller? That's a good question. I don't know why, but I would imagine it has something to do with engineering and cost, and it might actually be cheaper to have a bridge that mechanically moves rather than a bridge that's just tall enough to allow tall boats to go in. I tried my best to demonstrate the concept of a drawbridge here. The bridge is opening up so that the sailboat can come through. And so this bridge really does remind me of the conditions needed for a triangle. I have 2 questions that I'd like to discuss about this, and hopefully from these questions we can understand what's needed to happen to create a triangle. All right, so the first question is, how should the bridge close? When this bridge closes, how should it sit, right? How should I don't know what these are called, the draws, I don't know, the wings, I don't know what they're called, but how should these close so that it's a properly working drawbridge? So why don't you take a second and think about that, hit pause. All right. I would say it should close so it's flat, right? These guys, when they fold down, should be flat. I guess it would be shut, or I guess it should close. Now, what that means is that the distance from one side to the other is the same as the 2 parts of the drawbridge, right? And there's some exciting writing happening right now. So the distance from one side to the other . What do I call these? The 2 parts that open? Kind of get a segment addition postulate vibe out of this, all right? So this thing is working properly. When it shuts, it should be flat. Okay, so the second question is, what could go wrong? That's always a question you need to ask yourself when you're building something. What could go wrong? Well, why don't you hit pause and see if you can think of 1 thing or maybe 2 things that could go wrong, 3 things maybe, and hopefully you hit pause and thought about it. So, well, first thing that could go wrong is it just stops working and it's stuck like that, right? And you would have to literally launch over, and which I doubt they would let you do. The second thing that could go wrong is that these are too short. Right? The pieces that open are too short and they never meet, right? The second thing that could go wrong is that these pieces are too long. They're too long. Is it O or OO? I think it might be O. And if they're too long and the bridge is closing, that means it doesn't get to be flat. And what that means is we now have the condition to create a triangle. So they are too long, and this what creates a triangle. And I'll try to very quickly draw the bridge. Please forgive me for my lack of artistic talent. You got to realize that took me a long time to draw. So it goes like that. You know. Oh, let's just say it's closed. So these sides are too long. You're going to be left with something that looks like this, right? And this is not a very good bridge to be crossing because, you know, people, this is not very good. I apologize. Hopefully the idea is there. So these sides being longer than that is going to be the necessary condition for the triangle. And I'm looking at this and this is terribly drawn, but that's why I'm a math teacher, not an art teacher. But if they're too long, they never close, they catch each other, and we make a triangle. So remember, I wanted to investigate the conditions needed to create a triangle. I'm going to go a little bit further with this, so let me come back and make this a little bit more mathematical and explain with you know, some concepts such as greater than or less than to make the point. So let me clean this up, and I will be back. I'm back, so let's go ahead and continue with our first goal here. And remember, we were investigating the conditions needed to create a triangle. So the bridge example that wouldn't close is an example of the triangle inequality theorem. So when it didn't close, we created a triangle, which states, and now I'm going to make this more mathematical, which states that any two sides of a triangle must add to a length longer than the third side length. The third side's length. That was not very good grammar. So here's an example of the triangle inequality theorem. So I have length AB, length BC, and length CA, where the length of AB plus the length of BC must be greater than the length of CA. It must also be true that the length from B to C plus the length from C to A must be greater than the length from A to B. We also have the length from C to A plus the length from A to B must be greater than the length from B to C. So any two sides of a triangle must be longer than the third. That's what this is saying. Let me write that out. That's what this is saying. All right. Now, we can also use the triangle inequality theorem to find possible lengths for an unknown side, and we know two side lengths. So what I'd like to do is I'd like to just focus on length side BC. Okay, let's focus on length side BC. The length of BC. Let's focus on the length of BC. We know that the length of BC has to be shorter than the length of CA plus AB. We know that. But here I have two other inequalities that have the length of BC in it. Now, the first inequality, if I subtract the length of AB to both sides, so I'm going to put a mark there. The second one, if I have this guy, the length of AB plus the length of BC, we know that that's longer than the length of CA. But I want to isolate this. So if I subtract the length of AB to both sides, we know that the length of BC must be larger or longer than the length of CA minus the length of AB. I can also rearrange this. If we have the length of BC plus the length of CA, and that's greater than the length of AB, and we subtract the length of CA to both sides, I'm sorry to get really low here, that means that the length of BC must be larger or longer than the length of AB minus the length of CA. Now, let me explain these two inequalities. One of these is going to be positive, the other is going to be negative. Okay? And the length of BC has to be longer, obviously, than the negative, but it has to be longer than the positive version. So whatever value you get out of these, make it positive, and that's going to be the minimum length of the side BC. I'm going to come back and do an example of a triangle where we know two side lengths, and you're going to see this actually work out, and we can figure out possible lengths for the third side length. So let me clean all this up and I will be back. I'm back, so let's go ahead and wrap up the first goal. And remember, our first goal was to investigate conditions needed to create a triangle, and we saw that a triangle would be created if two side lengths were longer than the third faulty drawbridge. So let's go ahead and just jump into our first goal, and it's to, we'll do an example here. Our example is to determine possible side lengths for a third side of a triangle with two given side lengths. And remember, two side lengths are longer than the third length. So, I know that 8 plus 13 must be bigger than x, which is my unknown length, which means that, let's see if I can add, the third side length must be shorter than 21. That's one possibility. I know that 8 and x must be larger than 13, or that the unknown length must be larger than 5. And the final possibility here would be that x and 13 have to be longer than 8. Remember, the two side lengths are longer than the third. 8 and 13 are longer than the third, x and 8 are longer than the third, x and 13 are longer than the third. So if I get the x by itself, we're going to get that the length obviously has to be longer than a negative. Remember, in the previous section I said it's going to be the same number, but what was going to happen was the sides are going to be opposite. So what this means is that the possible length for the third side is going to be shorter than 21, but longer than 5. Now, it can't be less than or equal, because if it's less than or equal, we get to a drawbridge that's functioning, okay? Now, I wanted to create a side that's the shortest side of the triangle, and I also wanted to create a possibility of a side that's the longest side. So, for example, if I said x was 6 and x was 20, 6 would be the shortest side, or 20 would be the longest side. And what I'm going to do is I'm going to do a little trig, which you don't necessarily know yet, but I want to use this example to talk about this last goal. So I'm going to check off the first goal. We know how to determine possible side lengths. And so now we're going to look at understanding how side lengths of a triangle impact opposite angle measure and vice versa. And I'm hoping that I can explain it using the example that we just did. So let me go ahead and clean all this up and I will be back. And where did I hide that lid for myself? I hid it right here. Okay, I'll be back. I'm back. So let's go ahead and now jump into the second goal, and that's understanding how side lengths of a triangle impact opposite angle measure and how angle measures of a triangle impact opposite side lengths. Okay, so I'm going to actually read the goal instead of tell you the goal and then read it again. I'm going to shorten this. So our second goal. We saw from the previous example that a possible side lengths for the third side of a triangle with lengths 8 and 13 were between 5 and 21. I'd like to look at two possible triangles. One with a third side length of 6, a second with a third side length of 20. Okay, let me point something out real quick. 6 is going to be the shortest side for the first example. 20 is going to be the longest side for the second example. Remember, I can pick any value between 5 and 21. I picked a value that would be the shortest, and I picked a value that would be the longest. All right, so let's move on here. I used trig to calculate the angle measure. So if I know all three side lengths, I can actually calculate the angle measures. You'll learn about that later, but don't worry about that now. It's not part of this school year. We want to pay attention to side lengths and their opposite measures. Remember, this length is the shortest of these two. This length is the longest of these two. And we want to see how the angles interact with these. Okay, notice opposite the longest side, which is 13, we get the largest angle measure, which is 136. So 13 is the longest length. Opposite that is the largest angle at 136 degrees. Opposite the shortest side, which is 6, we get the smallest angle measure, which is 18.7. Opposite the median length, which means the length in the middle, 8, we get the median angle measure, which is 25.3. Hopefully you're recognizing a relationship between the longest side length and the largest angle, the shortest side length and the smallest angle, and the median side length and the median angle measure. So hopefully you're recognizing something going on here. I'm going to go ahead and erase all this, set up the triangle with the longest length of 20. Think about where you think the biggest angle must be, where the smallest angle must be, and the median measure angle must be. So let me clean all this up, and I'll be back. I'm back for the last time, I promise. So let's go ahead and finish the second goal. Remember, our second goal is understanding how side lengths of a triangle impact opposite angle measures and how angle measures of a triangle impact opposite side lengths. I think there's supposed to be an S right there, but oh well. All right, so let's continue with the second goal. Now we're going to look at a triangle with side lengths of 8, 13, and 20. Again, the angle measures are calculated using trig. Don't worry about how I calculated those. They're not part of this school year. You'll learn about that later. Remember, 20 is a measure that I was allowed to have for the third side, knowing that two side lengths were 8 and 13. They had to be between 5 and 21, so I picked 20. Here is an actual scale version of that triangle. And again, notice opposite the longest side, which is 20, we get the largest angle, which is 143 degrees. Opposite the shortest side length, which is 8, which was the median length in the previous problem. Opposite the shortest length, 8, is the smallest angle, 13.8. And opposite the median length, 13, which was the longest length in the previous example, is the median angle measure of 22.8 degrees. Okay? This pattern is always true in triangles. Opposite the largest side is the largest angle, opposite the shortest side is the smallest angle, and opposite the median length is the median angle measure. It's always true. Now the converse, remember, converse is a fancy way to say you switch the order. The converse is also true. Opposite the largest angle is the longest side, opposite the smallest angle is the shortest side, and opposite the median angle measure is the median length side. Should put a side there, but that's okay. Alright, so remember this section, and I don't remember what it's titled, I'll tell it correctly in the title when I title it, but remember this section is about finding third possible side lengths of a triangle, and understanding how lengths and angles are related in a triangle. Okay, so make sure you know how to do that. You might be asked, I'm not going to tell you how to do the homework. These are the tools that you need to do the homework. Alrighty, so I'm going to go ahead and end it here. I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.